In this video, we're going to take a look at repeated factors for partial fractions. Now, if we have a repeated factor within the denominator, we can still split our fraction into partial fractions. However, we do need a slightly different method to do so. So what I can see here is I have this algebraic fraction. So I've got 3x squared minus 13x plus 2, and that's all over x minus 2 all squared times x plus 1. Now, like we said, we can split this here into partial fractions, and if I was to do so, I'd obtain the right-hand side here, where a, b, and c are constants to be found. So, like you can see, when we have a repeated factor here, so my repeated factor is this x minus 2, the way that I deal with this repeated factor here is we set up three fractions in this case because we have three factors. And because I've got this x minus 2 all squared here, to begin with, we have a over x minus 2, so I just take one lot of that. Then we have b over x minus 2 squared, so I've got x minus 2 times x minus 2 there in that denominator. And then finally, for my final factor here, nice and straightforward, just like we've seen for the previous examples, that would be c over x plus 1, okay, that final factor there. So the actual method then to find the values here of these constants a, b, and c is the exact same as we've seen for the previous few examples. So we start by obtaining a common denominator. So in this case, my common denominator would be x minus 2 all squared times x plus 1. So to begin with here, I'm going to get a lots of x minus 2 times x plus 1. So a lots of x minus 2 times x plus 1. Okay. Then we're going to get b lots of x plus 1 because that's all I need here to get that over a common denominator. So b lots of x plus 1. And then finally here, for my final term, I'm going to times this here by x minus 2 all squared. So we get plus c times x minus 2 all squared. Okay. So now my common denominator here would be x minus 2 all squared times x plus 1. So I'm going to get x minus 2 all squared times by x plus 1. Okay. And again here, what I do now, once I've got this over a common denominator, is I equate the numerators here. So in other words, this numerator here is equal to this numerator here. If I write that out in full, we get a lots of x minus 2 times x plus 1. Let me redo that bracket, it's not the neatest. Let's try again. So redo that bracket there. So x plus 1. We then have b lots of x plus 1. So plus b lots of x plus 1. And then finally c lots here of x minus 2 all squared. Okay, and this is identical then to 3x squared minus 13x plus 2. So I write that down in full. So 3x squared minus 13x plus 2. Okay, so now that we've equated the numerators here, what we do now is we use substitution. So what values of x can I pick here to eliminate these constants and then solve for the remaining constant? So for example here, if I let x equal, say, 2 here, if I let x equal 2, what would happen? Well, I'm going to get 2 minus 2 there, so that would be 0. So this a term here would disappear. The same would happen here with the c term, and then we'd go on to solve for b. Okay, so in that case then, I'd get 2 plus 1, which is 3. So I'm going to get 3b here. I get 3b is equal. So now I get 3 lots of 2 squared. So 2 squared is 4, times that by 3, I get 12. I've got minus 13 times 2, so that's minus 26. And then finally plus 2 there. So 3b in that case then, 12 plus 2 is 14, minus the 26 gives me minus 12. So we get minus 12 there. And then finally if I divide both sides by 3, we get that b is equal to minus 4. Okay, so that's the first value found, or the first constant found. So now what else can I substitute in here? So now if I let x equal minus 1 here, Okay, so if I let x equal -1, what would happen here? Well, this would be -1 plus 1, so that would be 0. So this term here would disappear. The same is true here then for this middle term. So -1 plus 1 is also 0. So that disappears. And then we can go on to solve here for c. So I'm going to get -1 minus 2. So that's -3. If I square that, I get 9. We get 9c is equal. So I'm going to get 3 lots here of -1 squared. Well, -1 squared is 1. Times it by 3, I get 3. Minus 13 times -1, that's plus 13. And then finally plus 2 there. So I get 13 plus 5, giving me 18 there. So 9c equals 18. So therefore c equals 2, dividing both sides by 2 there. And then finally, we need the value of a. However, you might notice a bit of an issue here, because the only two values we can actually substitute into this expression here to actually eliminate terms is x equals 2 and x equals -1. So how do we deal with this issue here? Well, to find the final constant here, the method that we use is to equate terms. So we're going to equate terms here. So equate terms in x squared. Okay. So if I equate terms in x squared here, what would that look like? Well, imagine you were to expand these double brackets out here. Okay. The coefficient of x squared here would be 1 if I was to expand these double brackets. If I was to then times it by a, I'd just get 1 ax squared. So in other words, a is just simply 1 in that case. Okay, if I'm equating the coefficients here for x squared. So I'm just going to simply get a there. Doing the same here then for c. Again, if I expand these double brackets here, the coefficient of x squared would be 1. That would just be 1c. So I get a plus c. And then finally, what about the coefficient here for this x squared? Well, that's 3. Okay. So a plus c equals 3. However, we do know the value of c here. C equals 2. So a plus 2 equals 3. Nice and straightforward then. A equals 1. Okay. And like you can see then, what we have now is the three constants that we needed. So a, b, and c. So finally then, just like we've seen now for the previous examples, all I'm going to do is just rewrite this here and substitute the values of a, b, and c in. So in that case then, 3x squared minus 13x plus 2 all over. So I get x minus 2 all squared times x plus 1. That is identical then. So I'm going to get a over x minus 2, so that's 1 over x minus 2. I then got b over x minus 2 all squared, so b is minus 4 here. So minus 4 over x minus 2 all squared. And then finally c over x plus 1, where c is 2, so plus 2 over x plus 1 there. Okay. And there we have it. So the value of a is 1, the value of b is minus 4, and the value of c is 2 there. So like you can see, dealing with repeated factors for partial fractions, nothing too challenging. We've just got to remember the key fact then that we need to set it up like this here, and then the method is almost identical. The only difference is to get the last term then, or the last constant, we usually need to equate terms. Okay. But there we have it. So that brings the end of this video on repeated factors for partial fractions.